Hey everyone, hope you're having a great day and welcome to the channel. So today I'm going to be throwing a brand new lithium into this Tomerlin cart that I have right here. And what that's going to be is the 51.2 volt, 105 amp hour Vatrer battery. This is going to be their complete kit to convert a cart from typical lead acid into lithium. This cart is also not a stock Tomerlin cart. It is currently running a Navitas AC swap inside it. So it's the 600 amp controller from Navitas along with the 5 kilowatt motor. And so we'll really be able to put this battery to the test against some of the higher output that this controller will demand. So let me bring it in a little bit closer so you can see what all this kit comes with, and then we'll get it put in the cart. So right here we have the 105 amp hour 51.2 volt battery. It weighs right around 100 pounds, just a hair over that, so definitely something to be careful when installing it. There's your onboard charger, along with the end that will plug into the battery itself, which plugs into this, and then this would be into an extension cord to the wall. Or what I typically do is I will put an adapter on the cart, which is a port that I can then just plug an extension cord into the side of the cart. Over in this last box, you have the battery meter right there, which will show your voltage, discharge, charging, all that kind of stuff. There's the cable to connect it to the battery. And then I believe under this, you have all of the mounting hardware for the battery, for the charger, and for the meter. There's also a little bit of literature here, which I'm not going to bore everyone with. But basically, this battery output is 200 amps continuous, 400 amps for 35 seconds, and then I believe 600 amps for 5 seconds, which is a ton. Even though the Navitas controller is a 600 amp controller, I think the most I've ever pulled from one is around 350 amps. So that should be, this battery should be more than sufficient to power this entire system here in the cart, but we'll definitely test that out. So taking a little bit closer look at the dimensions of the battery, at the base, which is going to include the width of the mounting plates, you're 19 and 5/8, maybe just a hair over that. The top, including the lid, 19 and 3/8, just a hair over that. And the width of the battery, gonna be right at 11 1/4, just a hair under. Width of the lid, gonna be right at 12 1/2. And then the height of the battery, it's gonna be right at about 9 1/2 to 9 3/4, including these handles right there. Taking a little bit closer look at the inside, it is very easy to remove, just screws all the way around. Everything looks to be very professionally put together. It looks like all the hardware is marked, which I would assume has to do with just double checking that everything is torqued down as it's all put together. On this side, you've got obviously your positive and negative terminals, on-off switch, Bluetooth antenna, and then this communication port for the battery meter itself. All right, so now it's time to install the battery. I did remove the batteries that were in here. It's actually a really nice battery tray in here because there's no pieces of angle iron in the way because it just had this plastic tray sitting in there that all the batteries were on. So really I can just drop that battery, put it wherever I want in here, and then bolt it down. We should be good to go. Like I said, this is running the Navitas controller. Kind of hard to see, but back there is the motor as well. Yeah, I'll get the battery set in here. We'll get it wired in and then see if we did everything correctly. All right, so now I'm gonna wire in positive and negative side of the battery. On this is the connector for the charger. The brown wire is the positive. It goes to the positive side of the battery. Blue to the negative side of the battery. This cart is running a 48 volt EZO TXT chassis harness. So this wiring might be different for a Tomerlin, but for an EZO TXT 48 volt, really all you have to do is positive and negative, and then the charger. There's nothing else that needs to hook into the battery unless you have a voltage reducer to go to it, but it should be pretty simple. We'll get this connected and then test it out. All right, so got positive, negative wired in. Let's turn the battery on. turn back to run, turn the key on. Oh, probably put it forward. And we're moving, reverse. Yep, looks like we're good to go. All right, so got it all wired in now, so we're gonna take it out and give it a few different kind of performance tests. I'm gonna be looking at acceleration and then what we're gonna get for top speed as well. I do have the app currently on the Navitas controller set at 600 amps of max output. I would be pretty surprised if we got anywhere near that coming out of the battery, because I just don't normally see that. But either way, we'll test it out and see what it does. Looks like we can pull the wheels off the ground, but don't pay any attention to that terrible bump steer. I'm moving on to the range test. Just to keep everything level with what I've done in the past, I have the controller set at a max output of 200 amps. I have on the Navitas on-the-fly controller, top speed set to max. I have acceleration set to the recommended setting, and then the regen also set to the recommended setting. All right, so I finished up the range test, and kind of like what I expected, I got right at about 30 miles of range. out of this battery. I was running it pretty fast. I was averaging around 27 miles an hour, pretty much the entire drive. I think I topped out at, I believe, 38 miles an hour, which is actually about 3 miles an hour faster than I normally will get on my EasyGo TXT. Now, this is obviously a Tomberlin. It's a little bit different, although it is heavier than a TXT. Maybe the gearing is slightly different in it that caused that higher top speed. But either way, it had really good performance out of this battery. And I only noticed that it started to slow down as we got a little bit later in the ride when under acceleration. And I actually think that was due to more of a motor controller safety. I was noticing the temperatures were getting a little bit hotter, and I think that's what was causing the slowdown a little bit on it, mainly just an acceleration. But super happy with the results that I got out of this battery. One thing that I almost forgot to mention is the app that you can actually use to monitor this battery as well, instead of just using the display that it comes with. The app is super helpful. All right, so in conclusion, like I said, I'm super happy with the results that I got from this battery. I've installed multiple of these 105 amp hour batteries. I've also installed multiple of the 150 amp hour batteries, 48 volt, and then as well as the 72 volt packs. I've had absolutely no issues with them. Every single one of them has performed at least to the standards that they say, but most of the time above the standards. I've never had one shut off due to tripping the BMS from trying to pull too much amp from the battery itself. And I do run these on pretty upgraded controllers. So they are being pushed really to the current limits that they have. And I'm still not running into any issues. The next step for this card is actually going to be installing the Navitas 850 amp 7.5 kilowatt system into it. And then we're going to really be able to see when we push these batteries to the limits of what that new controller can do along with the motor. I don't know what it's going to do as far as if it's going to adjust the range at all, so we'll compare that. Same with the top speed, because I'll just be using the same exact battery in that. So we'll get a really good comparison kind of head to head on just the differences of those controllers. So if you're interested in checking that out, make sure you're subscribed so you don't miss out, and I hope to see you on the next one.